Hi, welcome to ESP32 tutorial from Robojax. My name is Ahmed Shamshiri, presenting this tutorial from Canada. In this tutorial, we are going to learn how we can control the position of a servo motor using ESP32 microcontroller Wi-Fi Bluetooth unit over the Wi-Fi from the theme network of your home or business. Here is a screen. I can reduce the angle and it moves, or I can increase it, or I can go directly 180, 0, 90, or 135. That's 0. For the rest, you can read it. You can get the code for this by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. Before I start with anything, if you just need the code to run it, you can grab the code and start using it. But if you want to learn, you have to watch this video step by step without skipping. Because many times people ask me questions in the comment, I read all those comments. People ask a question that has already been answered in video and they've skipped. So please make sure to watch the video if you have any question, because with my best knowledge, I will not leave anything out. I will try to explain everything. In my all videos, under the video in the description, click show more and you will see the link directly to different section of the video. You can click on any of these links to jump directly to different section of the video. A separate video how to control the servo motor using ESP32 without Wi-Fi. Make sure to download the library and run it and make sure you are able to control the position of the servo. Once that is done, then come to this video. Otherwise, you will have issues and there will be too much complication between the code and understanding. The link for that video is below this video in the description. In any application, you need to control a smart car, a smart arm, or whatever it is over the Wi-Fi. In this tutorial, I'm going to show you how we can use this ESP32 to control single motor, because multiple motor will need a little larger screen and the code will need to be modified. I will post that separately with different feature, but this is one of the features that majority of the time people needed to move a different angle. I will create more videos related to this, but this is just a basic servo control. And I'm connecting it to external power because the servo cannot function with the power that's provided with the 5 volts of this one. So 5 volts is separately connected. This is a simple HTML page that I've opened. I have 2 buttons here at the beginning and the end. Every time you click it, ESP32 reduces the angle by the step angle that you set in the code. And every time you click on the plus, it will increment or increase the angle with an amount of step that you set in the code. These are just some random value that I put that I thought maybe you will need these values, but sometimes people will just need 0 and 180. And I'm going to explain it to you inside the code so you can put any other angle that you want and more buttons can be added. Click on this. If you pay attention here, it says /. This is the URL that we are accessing, either IP address or Robojax ESP32, and then /servo ? Do S1, which means servo 1 less. If I click on this, it says do S1 more. So this is increasing and this is decreasing, and also the value is reflected on the screen. But if you click on this, for example 90, it says move ? Angle equal 90, and this one says angle equal 135. So you can add more, just change this number and the code that I've written will take care of it. To see the source code, press Ctrl and then U, and this is the code that is behind the scene that is displaying all those values. So let me briefly explain the servo motor. Servo motor is a type of motor that the shaft can be controlled to move only 180 degrees or half a circle, something like that. And then you can control precisely where it should be between 0 and 180 degrees. There are also other types of servo motors that, for example, there is something called continuous servo, which I have the link below. It will rotate 360 degrees and you can control it. But these are the most common one. And also you might get this type of servo motor, which is very heavy with high torque. It is the same way it can go 0 to 180 degrees and it will stop. So this is MG966R version, and this is the metal gear. This is all metal, and this is a plastic gear, so this will be much cheaper, like 3 or 4 or 5 times cheaper than this, but in general this is the operation and you can control it. So the servo motor has 3 wires. The darker wire is the ground. The 5 volts is always at the middle in case you make mistake in terms of connection in RC or car or airplane. So the middle is always 5 volts, and this is the signal. You might see it as a black wire on this side, red is always red, and this side you might see white, but doesn't matter. So they're the same. Configuration is exactly the same: ground, 5 volts, and signal. Also, I have another video explaining how to control a servo motor using ESP32 without potentiometer. The link for the video is below this video. Also, I have a video explaining how to control servo motor using potentiometer and ESP32. The link for that video is below this video in the description. Also, I have another video explaining how to control more than one servo motors using ESP32. The link for the video is also below this video in the description. Now let me explain the wiring. This is my servo. I've connected it from male to female at this point, so it's easy for me to connect it. And the 3 wire that we have is one is brown. Brown is connected here to the ground. The brown is a ground. It has been connected to GND, and orange is the signal pin. It is connected to pin 14. You see G14, or in some boards you will see it as number 14. In this board you will see the number 14, not G14. Does not matter. These are connected here. Now from my power, external power, this is coming from my battery, 5 volts, and I've connected the positive directly to the servo, and here. So this goes directly to the servo, and the ground is connected to another ground of ESP32 at this point. You will have multiple ground here, ground there, and more ground here. You can connect it to any ground that you want. In order to start using ESP32 with Arduino IDE, you need to prepare Arduino IDE for that purpose. You will copy and paste it here. You see it says package ESP32 index.json at the end. So once you paste it here, click OK, click OK. This is telling Arduino IDE where to get the board driver. Click on Tools, and then Board Manager. And here, wait for this to complete at the bottom, this bar graph. And then type here ESP32. You see ESP32 by Espressif Systems. It says installed. In your case, it will not be installed. You will have install button here. Click on it, and it will take maybe a few seconds or a minute. And the installation, once is completed, click close. Now we have to tell Arduino IDE which board you're working with, because the driver is ready. Click on Tool, Boards. This is Arduino IDE which you will usually work, but scroll down until you see a line below that. All of these are ESP32, and ESP32 rover module is the one that you click and select, and the dot will appear. Now we have to select the port. For that, we have to find out which port we are using. Right click on the start menu, device manager, and you see port. Click on this arrow to collapse it, and mine is using COM port, Silicon Lab. If I disconnect it now, you will see that it will disappear. Connecting it back. So this is COM6. Note that. Click on Tool, Port, and you will see COM6 is already selected, and now you can write your program and run it. Let me now explain the code. You have to download and install the Servo library. I will provide you as a zip the Servo for ESP32. I've taken a library that was in this address. It was not working with ESP32, and there was a conflict between current Servo and that Servo, so I modified the code. The link is also provided here. The credit goes to the original creator. So you will download that zip file. After that, you have to include it. Click on Sketch, include library, and then add .zip library. Then point to where you have saved it. For example, if it was inside download, click on PC, download, and select that zip file. And if it, for example, if this was your zip library, click open. After that, make sure to close Arduino and then reopen it so you can see it in the example menu. Go to File, Examples, and you will see Servo ESP32, and here simple servo underscore Wi-Fi. I have simple servo and then simple servo Wi-Fi. Make sure to run this first before doing anything, but this is with Wi-Fi. Once you open it, you will see that there is an .h file and this file. So that is the HTML page. You will I will explain it later. Include servo underscore ESP32. This is part of the library. And there is a pen that we define as a static constant integer servo 1 pen, pen 14. Your module might have it as 14 or G14, so you connect it directly to that pen. And then from this class, we create an instance of it, and we call it servo 1. So inside the code, we will always refer to this when we use it. And here for servo 1, we set an angle. This is initial angle, and later on this will be updated and the servo moves to this angle. So make sure to set the angle that you want the servo to start. And then integer, we define another variable, servo 1 step. You can set it to 5, and that is the this increment. When you click it, you see it goes by 20 degrees. If I go to 90, you will see 90 plus 20 is 110. So this is 20. You can change it to 5 or whatever you want. And then servo angle in percent. This is a value that we need to convert it to show it here, because on the screen the values are displayed based on percent of the width of the screen. And then we have servo 1 angle minimum and servo 1 angle maximum. I set this so you have more option and flexibility, because in some applications you don't want the servo to go to certain angle. If you don't want to use it, leave it as is, 0 and 180. That's a default servo movement angle. But otherwise, you must have here smaller and you must have larger. If you put it in reverse, it will not work. Then this is the page that we have, the .h, and here we include 01 simple servo underscore Wi-Fi page.h. This file must be inside the same folder with this. It's automatically, if it's part of a library, it will be here. Let me show you. And it is here. You will see that this and also .h. These are extra files. So these two are part of the highlighted one, or part of the code that we are using. And the rest are from the code that is here. I've updated it. Let me show you. File, example, and then scroll down until you see this line below. This is for ESP32. And then web server and advanced web server. I've taken this and I've modified it. For example, this is the SSID of my router, and this is the password. And this is specifically for tutorial. I will shut it off so I don't worry if you know the password. But pay attention here for SSID. It must match exactly if it is uppercase or lowercase. Make sure to consider that. Otherwise, lowercase and uppercase are distinguished, and it's case sensitive. This is initializing the server, and here these are the portion that I have worked to prepare it. This is page header. This is inside this code here. I've increased the text so it is not viewable. Let me reduce it to 35 so we can see it. Page header 1, and that is the code that I have here, and this is a string variable. Now that portion of the page is here. Then we get the servo angle, which is defined at the top, which is from minimum and maximum. We are using this map function to convert it between 0 and 100, which is in terms of percent, and this is angle in percent. And then we add this at the end of the code. We concatenate this text. You see this inside double quote. We add bar 1 width. So for servo 2, we'll have bar 2 and so forth, and the width is whatever is the angle in terms of percent, and we put also the percent sign at the end. Then we concatenate the header portion of the header 2. Concatenate means add it into other piece or stitch it. So this is 2, and then the other portion, and then angle is displayed on the screen. This is actual angle. So we have, this is actual angle, but the width is based on percent. You see it can go 180. If you leave it at 180, this will be out of the screen because it cannot allow this, the width cannot be allowed to be over 180. So these portions are all needed. And then HTML page, here we use server.send of type HTML, and we send the content on the screen. This node handle was exactly as it is. If you type something here, you will see, for example, if you say, if you type here book, you will see it says book not found, URI. So we have to make sure that take care of the handling of not found. So I've not changed it inside the setup. We attached the servo1.attach servo1 pin, which is pin 14 defined above. I've not changed these. I've not changed these. Not that. And I've added here RoboJax ESP32. This is the URL that when you run it, you can open it like that, or you can use the address that I'm going to show you on the code. And this was just one line. I've added these 2 lines. If it is /servo, what to do? We say go to handle servo. If it is /move, go to handle servo angle. These are 2 functions that are defined at the bottom of the code, which I will explain. And these were already there. I did not change it inside the loop. This was already there, and I've added this line, servo1.write servo angle, and then we give it 20 milliseconds, and the loop will continuously take care of this. And this was just to print the angle on the screen, which you do need it. I've commented. If you want it to be displayed, just uncomment it, and it will be displayed on the serial monitor. Now handle servo will get this value. Do, we have servo. When it is servo, we have do here. When we have servo, it will come here to this portion. Let me repeat it again. If we have /servo, it goes to this portion, to this code. If it is /move, it goes to this function. Now I'm talking about this. Then we check server.argument. The argument that is coming is do, and then we check it. If it is equal, we have 2 equal sign, s1 less less servo1 less. If it is the case, then we get the angle and subtract the step angle that we set, 25 or 10 or whatever step that you set. And this portion, it will take care of it. If the angle is below minimum, which sometimes it goes below 0 or minus, so the job of this one is if it is below this, then we say angle is equal servo minimum. It will not allow it to go below minimum. Else mean if it is not S1 else, it must be S1 more. So then we add the positive, and then this will take care of the value above 180. And this servo angle is very simple. We get the angle, and then dot to int, we convert it to integer. Now we have it as an integer because the value that you pass here, these are always string. So we need to change the type. And here we compare it with a number. Now because it's integer, we can compare it. Otherwise you will get error. So servo angle is greater than 0, or these 2 pipe or vertical line means or. If it is smaller than this, then we take care of it. Otherwise we will reject the rest. Then we say angle, servo angle is equal this servo angle. This is servo angle 1, and we have converted the one. We put it, so this is controlling the servo, and the servo moves to that location. Handle root will take care of the root again when at the end of this function. The HTML page, This is the title, document type, HTML. These are needed for the page. And the most important part is that we have, you see here, servo question mark do, servo one less, and this is one button for the less, and then we have the bar graph, and then we have servo more. And these are our push buttons for the angle. As you can see here, that is for 0. If I space it properly, this is for 45 degrees. Move question mark angle equal 45, and so forth for 90, 35, 180, and just copy and paste it and make more angle if you want, but not above 180. It will be rejected. Anything below minimum and maximum will be rejected. Let me now demonstrate it. First, on your Arduino IDE, click on this serial monitor on the right side, or click on Tools, Serial Monitor, or press Ctrl-Shift-M. There is nothing. If I press this reset button, you will see that it shows 192.168.1.120, or you can access it at this URL. Just copy this and paste it. This will make it easy, because if this changes every time, this will not change. It will be easy, but in some cases you will face issue or problem. But in that case, use this. So whichever is easy for you, use it. And then let me just go here. If I put the number, as you can see here, it shows. I press Control and plus to increase the size on the screen. As you can see, make sure to put http://robojax ESP32 and then put /, and then this will also work. And here is the demonstration. I've connected external power, because this servo needs a lot of power when it moves from stop position, and the code is already loaded, and this was the default angle that you set. So I can go to any angle directly, or I can reduce it with this negative or positive. This is increment of 10 degrees. As you can see, you can change it. This is now 20 degrees. You can change it to 5 degrees or 1 degree, whatever you want, inside the code that I just shown you. Please post your comment or question below the video, and make sure to subscribe if you want me to reply and answer your questions. Now let's try it on my mobile device. I have to make sure that I'm on the same SSID of my home Wi-Fi, because this the one that I'm using is for YouTube tutorial. Let's go to the settings and wireless networks, and then Wi-Fi, and here I'm connected to RoboJax, so it will work. If not, make sure to select the SSID of the device that you put the password for in here. Now let's go 192.168.1.102, and then press enter. And here is the screen, and the servo is connected, ready. So when I touch 180, it will 180. Let me go for the plus, slowly increase it with the increment of 20. 150, it should be 130, so 20 if I go to 0. You see this is not fitting properly, but it's okay. That's 0. For the rest, you can read it. As you can see, it's responding perfectly to Wi-Fi control. Thank you for watching. This was how to control a servo motor using ESP32 over the Wi-Fi. If you learned something and found it useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, post it in the comment section below. And if you are my subscriber, I always try to answer and reply. If you want to get updates of my upcoming videos, make sure to subscribe. So go to the address and let's type it as 192.168.1.02. So, and then press enter. If it doesn't work, it means that my Wi-Fi, my phone is not connected to the same SSID.